is the introductory activity part A, effective concentration. And in the petri dish we have iron and potassium thiocyanate. Now it's light yellow. So basically throughout this reaction, the change of color, based on the change of color, we can identify either more reactants or products were added into this reaction. So a darker color will signify that more reactants were put in there because to maintain equilibrium, more products have to be made, and the product is orange. And when it clears up later in the video, it shows that more products are put in the reaction, so that the reaction shifts back to the left and the color goes back to light yellow or transparent. And then when the color doesn't change, it means that whatever you added in there probably didn't react with anything at all, or it wasn't enough, or it wasn't an excess. This is introductory activity part B, and A is the test tube being cooled and B is the test tube being heated. From this obvious color difference, we can conclude that the reaction is exothermic. Looking at test tube B, when we add heat to the reaction shifts to the left, favors the reactants because of the clearer color, and it means that the reaction used a endothermic reaction to overcome the increase in temperature, and this suggests that the reaction is exothermic. And the color of A is darker, obviously, and this further proves that the reaction is exothermic. So this is activity B, formation of a complex copper ion. In the test tube we have copper sulfate solution, and we're dropping ammonium hydroxide solution into it. Adding the ammonium hydroxide shifts the reaction to the right side, making more product, which is the complex copper ion solution. And as you can see, there is a light bluish precipitate forming at the bottom when ammonium hydroxide is added, and when you keep adding ammonium hydroxide, the solution turns dark blue because that is the color associated with the product. When you add you have an excess of reactant, in this case ammonium hydroxide, to maintain equilibrium, more products will be made. That's why the color is going to be dark blue. And similarly, as the activity suggests, if you add hydrochloric acid, which decreases the concentration of one of the reactant, ammonium hydroxide, the reaction will turn back to the left and the color will be back to light blue.